Hello students. So in this video we are going to discuss basics of trigonometry, because in problem solving there are many trigonometric equations, calculations that will be coming. So we need to know the basics of trigonometry. Although you may be knowing, but we are going to just review it. Basics of trigonometry. Okay, so let's start. So first thing is we are going to discuss about trigonometric ratios or T ratios. What are trigonometric ratios or T ratios? So we can make a right triangle. Let us say that this is a right triangle. Okay, this angle is theta. Let's say this is hypotenuse h, this is the perpendicular, or this is opposite, and this is adjacent, which is the base. So base is nothing but it is adjacent side. H is the hypotenuse here, and P is opposite side, okay. So now what are the trigonometric ratios? It is the ratios of the sides. So first there are 6 trigonometric ratios. Sine theta, with respect to this angle in this right angle triangle, sine theta is defined as perpendicular by hypotenuse, P by H. Second is cos theta. Cos theta is defined as B by H, base by hypotenuse. Third is tan theta. Tan theta is defined as P by B, perpendicular by adjacent or perpendicular by base. So these are basic 3. Then there are other 3's. What are those 3's? Fourth number you can take. They are reciprocal of this. So if you take cosecant theta, that is reciprocal of sine theta. Reciprocal will become H by P. Similarly, we have secant theta. Secant theta is 1 by cos theta. 1 by cos will become H by B, right? Similarly, the last one, which is cot theta, is 1 by tan theta, and that will become B by P, right? So in this manner we should know all these trigonometric ratios: sine theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta. Okay, then let's move next. So we should also remember some relationships between them, basic relationships or basic identities, basic trigonometric identities. So if you take first identity, that is sine square theta plus cos square theta is equal to 1. Second, secant square theta minus tan square theta is equal to 1. Third, cosecant square theta minus cot square theta is equal to 1. Basic trigonometric ratios, all these are based on Pythagoras theorem. It is very easy to prove them, right? Okay, we are not just going into those very basic, just these formulas we need to know, right? Then there are other trigonometric identities based on compound angles and other things. So let us write some prominent or important trigonometric identities. They are also identities, but it is based on compound angles and other things. Okay, so identities based on compound angles. So first, sine A plus B. What is sine A plus B? Sin A plus B is sin A cos B plus cos A sin B. Okay. Similarly, what is sin A minus B? Sin A minus B is sin A cos B minus cos A sin B. Then similarly we will have cos of A plus B. Cos of A plus B will be cos A cos B minus sin A sin B. Similarly, we have cos A minus B. Cos A minus B will be cos A cos B plus sin A sin B. Okay, we don't have to write for tan A plus B. We can do that. Okay, for example, if you write tan A plus B, tan A plus B is tan A plus tan B by 1 minus tan A tan B. Okay, and similarly if you write tan A minus B, then what will be tan A minus B? Okay, so tan A minus B, tan A minus B, that will become tan A minus tan B divided by 1 plus tan A into tan B. So these are the very basic equations which are based on the compound angles. So you see 3 plus 3, 6 formulas are there. Still there are more and some important cases are there that also we'll discuss. Okay, let us take for example, if there is sine 2 theta, this is going to be useful very much. Sine 2 theta is nothing but sine theta plus theta. So you can apply sin A plus B formula. So this will become 2 sin A cos B. That means 2 sin theta cos theta it will become. Okay. Then similarly, what will be cos 2 theta? Cos 2 theta, what it will be? So it will become cos square theta minus sin square theta, which can be further written as 2 cos square theta minus 1, or it can be written as 1 minus 2 sin square theta. Okay, so from this formula number 2, we can also write as 1 plus cos 2 theta divided by 2 is cos square theta. This is an important formula. And then formula number 4, 1 minus cos 2 theta divided by 2. This will give sin square theta. So formula number 3 and 4 is very useful because it is changing the power. Second order trigonometric function is becoming first order. Okay, only thing is angle is changing. Okay, so these formulas are important. It will be used in calculations. Okay, then there are many other formulas that I will separately cover in a different session. Now let us go further to understand the values of trigonometric functions. Okay, values of trigonometric functions. What are the values of trigonometric functions? So there are standard angles. So we will take standard angles. Standard angles. What are the standard angles? So you can take the angle like theta. Theta you can take as 0 degree, then 30 degree, then 45 degree, then 60 degree and 90 degree. For these things we should know what is sin theta, what is cos theta, and what is tan theta. Okay, so let us write the values of this. Sine 0 degree is 0, right? Cos 0 degree is 1, tan 0 degree is 0 because tan is the ratio of sine by cos. Sine 30 degree is half. Cos 30 degree root 3 by 2, and tan 30 degree is 1 by root 3. Similarly, 45 degree, sine 45 degree 1 by root 2, cos 45 degree 1 by root 2, tan 45 degree 1. Sine 60 degree root 3 by 2, cos 60 degree half, tan 60 degree root 3. Sine 90 1, cos 90 0, 1 by 0, which is undefined, okay, or infinity, which we say undefined. Okay, so these are for standard angles which we can remember. Okay, so each column are the corresponding values and you can remember this. But beside this there are few angles, for example 37, 53, that also we should know, that is also going to be useful. So note here that if we make a particular angle, like for example if you take a triangle whose sides are in the ratios 3, 4, 5. 3, 4, 5 is a right triangle. Ratios must be 3:4:5. 3:4:5. It is the ratio of sides. Okay, sides ratio. If the sides ratio is this, then we can say that opposite of the smallest side, this angle is going to be 37 degree approximately, and opposite to 4, this is 53 degree, and this is of course 90 degree, right? Then you can write all these values. For example, if you take this is the angle theta, 37 degree, so you can write sine 37 degree, cos 37 degree, right? And you can write tan 37 degree. So sine 37, when you write opposite by hypotenuse, cos adjacent by hypotenuse, tan opposite by adjacent. Okay, so everything can be calculated. Similarly, if you are taking 53 degree, let's say you are taking 53 degree as this angle, then you can write sine 53 degree, you can write cos 53 degree, you can write tan 53 degree, everything. So sine of 53 degree will be 4 by 5, opposite of 53 is 4. Then cos 53 degree will be 3 by 5, and tan will be 4 by 3. So like that we can know about these angles. So 37, 53 degrees are standard angles also, because in many calculations you will be seeing that. Okay, then let's write some complementary angles and other angles we will see. So first you should note that if you write sine of 90 degree minus theta, that becomes cos theta. Similarly, if you write cos of 90 degree minus theta, that becomes sin theta. Similarly, if you write tan of 90 degree minus theta, that becomes cot theta. Similarly, if you write cot of 90 degree minus theta, it becomes tan theta. Similarly, if you write secant of 90 degree minus theta, it will become cosecant theta. Similarly, if you write cosecant 90 degree minus theta, it will become secant theta. These are for 90 degree minus theta conversion, but there is general rule that we will also discuss. Okay, so the general rule is important because we can convert for any angles in any quadrant. Okay, so let us see that rule, that is called all sine tan cos. Okay, all sine tan cos rule. So A refers to here all, S refers to sine, only sine. T refers to tan, okay, and C refers to cos. So what is this rule? So first of all we need to divide quadrants. Let's say this is x, x dash, y, y dash. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay. So let's say when angle can be anything. Suppose the angle first quadrant theta is between where to where? Theta is from 0 to 90 degree. Second quadrant theta is between 90 and 180. Third quadrant theta is between 180 and 270. Right, and fourth quadrant theta is between 270 and 360 degrees. So all sine, tan, cos means in the first quadrant all the trigonometric ratios will be positive. Here these are for positives. Okay, all trigonometric ratios are positive. Here sine is positive, so cosine will also be positive, right? Then a cosecant will be also positive, right? Then third quadrant all sine, tan will be positive, so cot is also positive, and here cosecant will be positive, so secant will be also positive because they are reciprocal. So this is the rule, all sine, tan, cos. Now based on this rule we can calculate. So let us take first example. Start with this example of sine. Sine n into 90 degree plus theta. You need to express the angle in terms of n into 90 degree. Here n is nothing but it's an integer. N is a integer. 1, 2, 3, 4 positive integer it can be. Okay. And theta is the angle. So now here one thing you should note that whether sine will convert into cos or not. Okay. So depending on the value of n. If n is equal to, let us say if n is equal to, first of all you have to take sine, right? Value of, what will be the sine, plus or minus. That sine you have to decide. First itself you have to decide what sine it will be, depending on what is this total angle. The total angle will help us to know which quadrant it is, right? Based on that you can define this sine. The sine will come first. After that you can tell whether n is odd or even. If n is even, then sine will remain sine only, sine theta. Otherwise this is the case when n is even. Okay, and in other case the sine, of course you have to decide, but this sine is going to become cos when this n is odd. Okay, so this sine we will decide based on which quadrant the angle is coming, and whether sine will remain as sine theta or sine theta will convert into cos theta, it will depend whether n is odd or even. If it is even, it will not change. If it is odd, it will change. Okay, so the same will also happen the reverse way also. Reverse way means sine will be converted into cos, cos will convert into sine. Similarly tan will convert into cot, cot will convert into tan. Secant will convert into cosecant, cosecant will convert into secant. So this we will understand when we will take quotients. Let's take quotients. For example, suppose if I have to find sine of 120 degree. So how do you express it, right? So 120 degree. So what you do is 120 degree. This is basically the method. 120 degree you divide it by 90 degree. You need to divide by 90. So 90 into 1, right? So how much is remaining here? So 30 degree is the quotient. So you can write sine 120 degree as 90 into 1 plus 30. Right? You can write it. Now you can see here this value of, first of all, this is 120 degree. It is in the second quadrant, right? It is in the second quadrant. The second quadrant sign is positive. Okay, so we give sign, and this is odd. You can see here the number 19 to 1. This is odd. So because it is odd, sign will convert into cos, and theta will be 30 degree. Okay, 30 degree is the theta. So then cos 30 degree is a standard angle, which we can write √3/2. Okay, so like this we can do. Take another example. Let us say this is cos of 135 degree. So again 135 degree you divide by 90. 19 to 1, 90. This is 45 degree. Okay, so you can write this as cos of 90 degree into 1 plus 45. Correct? Now you see here. So this is in the second quadrant, and cos is negative, so you have to put the negative sign, right? First you put sign. Then again this is odd multiple of 90, so cos will convert into sine. Cos will become sine. Angle is 45 degree, so minus sine 45 degree minus sine 45 degree, 1/√2. This is how we can decide it. Okay, so you need to practice more questions on this, and then you can do it. Okay, this is the conversion. So conversions will happen from which angle to which angle? If sine has to convert, sine will convert. Okay, in terms of sine will convert into cos. Sine will convert into cos if of course n is equal to odd, otherwise no conversion happens. Similarly, cos can convert into sine. Similarly, tan will convert into cot. Cot will also convert into tan. Conversion happens only for odd multiples. Similarly, secant will convert into cosecant. Cosecant will convert into secant if n is odd. So this rule is a very important rule. It is able to find, not only that, we can find various other angles also. Okay, various other angles also. For example, if they ask, let us say, what is sine of, let us check combinations of angle. Combinations of angle can also be applied. For example, if they ask, let us say, sine of 98 degree. So sine 98 can be written as what? 45 plus 53, isn't it? And now you know about these values. Sine A plus B, you can split it here. Sine A cos B plus cos A sine B, right? So then how do you write sine 45 degree value? 1/√2. Okay, and cos 53 degree. Remember, 53 degree means cos of 53 degree. What to do? If you forget, you can immediately draw that triangle. 3, 4, 5. Okay, so opposite of 3 is 37 degree, and this is 53 degree. So 53 degree cos, if they ask, that is 3/5, and this cos 45 degree 1/√2. Sine 53 degree 4/5. Then you can evaluate it. That will be the answer. So various possibilities are there for calculations. Okay, so for advanced level of questions, we can exploit all these tools. Okay, so thank you for your attention, and then we'll see further on trigonometric identities of complex formulas.